Hello there, I am very sorry about today's live feed not working. Issues with YouTube. I'm hopefully going to sort out those settings in my channel so that this doesn't happen again. So here is today's lesson. What I suggest you do if you are going to watch this now is pause the video now and have a go at those questions. So pause the video now. Okay, let's have a go at those questions then. So this is building on Wednesday's lesson where we looked at the area of a trapezium. We need to identify our parallel sides, so A and B are parallel sides, and our perpendicular distance, our height there between the two parallel sides. So the area is now given as a half of the parallel sides added together multiplied by the perpendicular height. So A and B and our perpendicular height. If we now sort out 5 plus 17, we get 22. So we add on the 3 for 20. There's 2 left over, so 22. And in this question here, I'm going to multiply by a half first, because that makes the answer 77 centimeters squared. Rather than do 22 sevens, it's easier to do a half of 22 and then multiply. 77 centimeters squared. Well done if you got that one right. Our second starter question, a little bit sneakier this time, because here are our parallel sides here in this right trapezium, and our perpendicular height is effectively this 3 meters here. So substituting that into the formula, we get a half of the parallel sides added together multiplied by the perpendicular height there, 3. Sorting out the addition of the parallel sides, that'll generate 11. And 11 times 3, so this time I'm doing this multiplication to give me a half of 33, and then a half of 30 would be 15, and a half of 3 would be 1.5, thus the answer would be 16.5 meters squared. If you're in year 7 or 8 and you've used a calculator on that question, that's not too much to worry about if you are watching this video back. Okay. Moving on to our next starter question. This was tricky. It was our silver question, and it's tricky because you've actually got two shapes here. You've got the triangle, so we've got a formula for the triangle, a half of the base times the height. We need to now work out what the base is. This is very poorly drawn because it was 15 meters there, so apologies that my drawing is so poor. So now I've got that, I can work out a half times the base of 15 times the height of 7. 7 15s, that seems the best way to go here. 7 15s. Well, what I can do there is I can do 10 sevens and 5 sevens, and I can partition the 15. So 10 sevens are 70, 5 sevens are 35. That means if you add them together, you get 105. I now need to do a half of 105. Well, a half of 100 would be 50, a half of 5 would be 2.5, and therefore again a half of 105 would give me 52.5 meters squared, and I can put that into there, 52.5 meters squared. The second shape, of course, is a trapezium. And this full length here of 24, when I add the 15 and the 9 together, is one of the parallel sides, and the other parallel side, of course, is the 15, with the perpendicular height being 8. So the formula for the trapezium is a half of the parallel sides added together multiplied by the perpendicular height. So a half multiplied by the two parallel sides, 24 plus 15, multiplied by the perpendicular height of 8. Now in this question here, it seems obvious to add these two together to get 39. 20 plus 10, 30, 4 and 5, 9. But it also looks obvious now, if I just write that out, to half the 8. And a half of 8 is 4, so I get 39 times 4. Well, I know that 40 times 4 is 160. That seems a lot easier to do. 4 4's given me 16, and then a power of 10, of course. So 4 less than 160 is 156. So just simply 4 less, because I've got 1 less 4. So it's just one way of doing it. I could have done 30 4's and 9 4's and added that together. So that's another way I could have found the 156. So the total area is 156 plus 52.5. Just lining that up there with my decimal points. So 5, that gives me 8, that gives me 10. I carry low, some people carry high, and some people carry super low, and that gives me 2. Put the decimal point in, don't forget about that, of course, and that's meters squared. Again, year 7 and 8, if you've used a calculator on that question, not a problem. Year 9, 10, you should be working through them without a calculator. They could turn up on a non-calculator exam. And finally, this little algebra puzzle, the perimeter all the way around the shape is 30 centimeters. I've got a side label 2x and x here. Well, of course, I can label those two like that. If I pick a vertex point and walk my way around the shape, I get 2x plus x plus 2x plus x. So walking down there for 2x, x, 2x and another x. Now that is the perimeter, of course, and I'm told that that's equal to 30. So I can form an equation, and I'll get 1 mark in the exam for forming that equation. 2x plus 1x is 3x, plus another 2x is 5x, plus another 1x is 6x. I know some of you will have just said, well, there's 4x and there's 2x, so you get the 6x. A times by 6 becomes a divide by 6, and x becomes 5. And that was in centimetres, I believe. And there we are. Well done if you got those questions right, especially the gold question at the end there. That is a great question to work on today. So let's now go through today's session. We're looking at BidMaths. If you watched yesterday's video, I looked at the fundamentals of BidMaths very much for our Key Stage 3 students, and now we're going to work on Key Stage 4 approach to this topic. So, BidMaths, what does it stand for? It stands for brackets, indices, divide, multiply, add and subtract. This is the order in which we will do the functions in the question, the operations in the question. We don't read left to right, which we do when we read a book, of course. That's how English works. But in maths, we look for the functions in a particular order. If we look at a couple of examples, if we look at these two examples first, we can see how BidMaths starts to work. And I've got indices and brackets to look at today, which we didn't look at yesterday. So, let's look at those first two examples. The best thing to do is to always write BidMaths down the side first of all. Looking for brackets, well, there aren't any. But there is an indice there, and there it is, the index, okay, the power of 2, which means I copy down everything else. I'm not going to touch any of that just yet. 4 squared, of course, is 16. I can now say I've done that. I'm looking now for a division. There isn't one. But there's a multiplication here, meaning I copy down the plus 3 and I don't do anything with that just yet. 2 16s give me 32, and then I can finish that question to find 35 as the final answer. So indice, then the multiplication, and finally the addition. So effectively we did the addition last as well. In the second example, again, write your BidMaths out and work your way down it. So are there any brackets? No. Is there an indice? Yes, it's here, meaning I will not touch the other two operations just yet. I'll work with this, and 6 squared, of course, is 36. Is there a divide? Yes, so this bit will get divided. The addition will drop down, and the 36 there. 8 divided by 4, of course, is 2, and 36 plus 2 gives you 38 for the final answer. So you can hopefully see with those two examples how we're going to apply BidMaths today. It's now your turn to have a go at some. There's the questions. As before, pause the video now. Okay, we're going to go through those answers then. Hopefully pause the video so you could have a go at them. And here we go. So section 1, question 1. We're going to write BidMaths out. I'm going to work our way down it. Are there any brackets? No. Is there an indice? Yes, meaning these two operations drop down. 7 squared is 49. Indice done. Are there any divisions in this question? No. Are there any multiplications? Yes, meaning the subtraction and the 49 will not work. We'll not do the 49 minus yet. We'll work with 6 times 3, which is 18. 49 minus 18 is our next bit. So we take the 10 off, which is 30. We take the 8 off, which gives us 31. First answer, 31. Very well done if you got that. Question 2, section 1. So, BIDMAS. Are there any brackets? No. Is there an indice? Yes. Meaning I don't touch the other two operations just yet. Now 2 to the power of 3 is 2 times 2 times 2. 2 times 2 generates 4. So I know that this part is worth 4. I then have to multiply it by another 2, which gives me 8. So 2 times 2 gives me 4, times 2 gives me 8. Are there any divisions? No. Are there any multiplications? Yes. So I drop the minus 4 there. And 5 eighths are 40. Take off the 4, 36. Final answer for question 2, 36. Looking at question 3 now. Again, writing out BIDMAS. Are there any brackets? No. Is there an indice? Yes. So I copy down everything that I'm not going to use just yet. 5 squared, of course, 25. Done. Any divisions? No. Is there a multiplication? Yes. Meaning I copy down the operation of 2 plus. 4 lots of 25 is 100. Give me a straightforward answer of 102 when I finally add as the final function there. Question 4, a little bit more tricky this one. So let's write out our BIDMAS. Do we have any brackets? Nope. Is there an indice? Yes. Meaning I copy down everything there. 3 squared, of course, is 9. So that's the indice done. Are there any divisions? No. Is there a multiplication? Yes, but here only. Meaning I copy down those two parts. 5 nines are 45. And now, because it's all addition, I can see there's 5 going to get added on to the 45, or I could generate the 48 and then the 50. Either way, I get an answer of 50. Very well done. If you had to go at them, of course, you can review them next week. You can come back to them, you can pause the video again and have another go at them if you didn't get them all correct today. Let's move on to section 2 now and have a look at a couple of example questions where brackets now are going to start to be introduced. Now when brackets occur, as you can see the top of BIDMAS is brackets. It means you work inside the bracket, but you apply BIDMAS inside that bracket. So inside the bracket you would work with indices first, then divisions, multiplications, additions and subtractions within the bracket. That will generate a number. When that number is generated, you will then go down BIDMAS again. I'll show you what I mean. So here are those two examples. So writing out BIDMAS, I can see I've got a bracket here and a bracket here, so I'm going to have to work with them first. Therefore, the division drops. Inside this bracket, I now work down BIDMAS. Well, I can see there's only one function, it's an addition, so I would do the addition first. If there was anything else, if there was a multiplication first, then an addition, I would multiply before the add. So 3 plus 9 generates 12. In this bracket here, again, only one function, and now I get a straightforward answer of 4. So it's inside the brackets first. So let's look at this example. I can clearly see there's a bracket, which means I'm going to have to work inside that bracket first. But what will happen is the 36 and the division drops, and this indice drops, that index drops there. The bracket now will generate an answer for here, which will then be squared. And of course that will occur next. But let's work in the bracket first. 8 minus 5 generates 3. I now look at the question, and yes, there is an index, it's here. And 3 squared, of course, is 9. 36 divided by 9. Well, just show you how I work with my year 10 and 11 students with that. We look at it from an algebraic point of view. We form the fraction. So 36 divided by 9 is 36 divided by 9. If I cancel this fraction down, they're both multiples of 3. I get 12 over 4. I get 12 over 3, I'm jumping ahead to the answer, as I always do. I get 12 divided by 3, which gives me 4. A lot of you will already know your 9 times table, and will know that 9 goes into 36 4 times, but it's just a nice another way of looking at the division there, with cancelling down our fractions. Okay, it's your turn to have a go at these. Again, pause the video when you are ready, and I will go through the answers. Okay, I hope you paused the video and had a go at them. Let's do these final questions before I talk about your challenge over the weekend. Okay, so yes, I can see clearly I've got the brackets there, so the division will drop. Inside this bracket there's only one function, and 3/8 are 24. Inside this bracket there's only one function, and 2 plus 1 is 3. Finally, 24 divided by 3 generates 8. Well done if you got that one. Question 2. Let's write out BIDMAS again. Brackets, yes, here, meaning I won't touch these parts of the question yet, and that index drops to there. Inside the bracket, quite straightforward, that generates 7, so a bracket done. Indice next, meaning I won't touch these parts, and 7 squared is 49. That's the index done. There's no divisions, but there is a multiplication here. 5 lots of 49. Well, I know 5 50s are 250 because 5 5s are 25, and again the power of 10. So if I go 5 lower, 1 less 5, I get 245. A number of ways of doing that as well. 5 40s and 5 9s, bring those together, and again you get 245. So the last job, add on the 7, and that gives us 252. Well done if you got 252. Very small but nice palindromic number there. Question 3 and question 4 getting a little bit more tricky now. So writing out BIDMAS, brackets yes here and here. So the addition and the 2 indexes will be done next. Obviously in order, so the indices will come first. Inside the bracket, quite straightforward, 8, and again quite straightforward, 3. So that's the brackets done. So I now do both indices, dropping the positive there, so I'm doing this index and this index. 8 squared generates 64, and 3 squared generates 9. I can now add them together to generate the final answer of 73. And the final question, a challenge question, that is an addition in there. Apologies for my writing. Are there any brackets? Yes, there are, and inside the bracket we've got 2 functions. So we go down BIDMAS again. So first of all, let me just copy down the 2 bits that are outside the bracket. I am actually going to keep the bracket because there's 2 functions. And I'm going to put a double underline under that and say, well, actually, I'll do that second. I hope that makes sense. So the brackets we lock onto first, but then we work down BIDMAS inside the bracket. We'll then work down BIDMAS again outside the bracket, as you'll see in a second. So 3 squared gets 9. So then we do the addition inside the bracket, which generates 11. I copy down, of course, the other 2 functions outside the bracket, which are still waiting to be performed. I'm now working down BIDMAS again. There are no brackets, there are no indices, there are no divisions, but there is a multiplication there, generating 66. I then take off 4 to generate 62. Quite a tricky question, that one. I hope you got it right. And if you've got a Casio calculator out there, you can use them, and they are fabulous because they understand BIDMAS. And if you type the question in, I hope you can see that there, if you type the question in, it recognises BIDMAS and it does the order of operation. It wasn't always like that. The calculators we had in the early 90s and the 80s didn't perform calculations with order of operation. Okay, your challenge for the weekend. On Monday I'm going to record a session. It won't be live, and I'll hopefully post that as close to 11 o'clock as I can. And I'll be working through the corbettmaths 5-a-day foundation worksheet for the 1st of May. I know that might sound crazy that I'm doing the 1st of May, but there is method in my madness, I promise you. I've put the link there, so if you don't have access to this sheet and you want to have a go at it before Monday's video, of course on Monday's video I will put this back up there and say to people, please download this and press pause now if you haven't had a go. All I can say is massive apologies again for not being live at 11 today. I'm hoping to work that out, make sure that is working for Tuesday. And last thing I'd say is thanks for watching.